Hi everybody. It's now been 2 weeks since we've seen each other, and a lot has happened in those 2 weeks, obviously, so I could understand if you might be a little rusty on the stuff that we talked about 2 weeks ago. With that in mind, I figured I would take this first lecture to quickly recap the stuff that we talked about last class, and then walk you through that practice homework problem that I left you with right before break. So we're going to quickly jump through, not even all of these slides, but review some of the stuff that we talked about just before break, before we then launch into some more stuff. For context, over the next couple lectures, we are going to focus exclusively on using regression to test interactions. We've tested interactions before. At the end of the fall semester, we learned how to do factorial ANOVA. But factorial ANOVA we can only use in a very specific situation, right? We can use that test when we have multiple independent variables, all of which are categorical, and our outcome is continuous. But we might have situations where we want to test an interaction, but our variables don't meet those criteria. So that's really what we're going to do over the next 4 or 5 lectures, is fill in these boxes right here. What do we do, for example, if we want to include a continuous predictor in an interaction? And what do we do if we want to test for an interaction where our outcome is categorical? So where we started last class was in this little square right here, where we had 2 predictors, one that was categorical, one that was continuous, and our outcome was continuous. So for example, we did that one example where we looked at the relationship between signature size, which was a continuous variable, and narcissism, which is a continuous outcome. And we saw that that relationship depended on a person's sex, which is a categorical moderator. And we found an interaction between sex and signature size on narcissism. The first thing we needed to learn in order to do that was called dummy coding. Dummy coding is what we have to use if we want to put a categorical predictor in a regression. And as we talked about last time, dummy coding just consists of recoding our variable as a series of zeros and ones. So if our predictor is dichotomous, it's very easy. We just designate one group as 0, we designate the other group as 1. We also talked about mean centering. Anytime we're testing for an interaction, we need to mean center any of our continuous predictors first. And mean centering just means that we're taking the mean of that variable and we're subtracting that number from each person's individual score. So if you had a score before mean centering that was exactly at the mean, your score after will be 0, right? So it actually makes alpha interpretable, as we saw last week. Having an average score means that your mean-centered score is 0. If your score is above average, your mean-centered score will be positive. If your score is below average, your mean-centered score will be negative. And then we talked about 4 steps to building and testing an interaction. First, we dummy code the categorical predictor. Then we mean center the continuous predictor. To calculate the interaction term, we literally just multiply one by the other. And then when we build the model, we're going to build it hierarchically. So we're going to put just the 2 predictors in block 1, and then we're going to add the interaction in block 2. So if you think of this in terms of factorial ANOVAs from last semester, what we're doing is we're putting just the main effects in block 1, and then in block 2 we're doing the main effects with the interaction. So the ultimate goal here is going to be to see whether block 2, the block with the interaction, is better than block 1, the block without the interaction. If that's the case, we know that the interaction is significant. So this is the example we walked through last class, signature size and narcissism. We wanted to know, A, is there a relationship between signature size and narcissism? And B, does that relationship depend on the person's sex? In other words, is there an interaction between sex and signature size? And we walked through the steps of how to build the interaction term and how to actually test it in SPSS. And we ultimately got to this point where we saw in green here that adding the interaction to the model made it better, right? In other words, block 2 was better than block 1, which tells us that the interaction was significant. Now, in situations like this, where we have one continuous predictor and one categorical predictor, testing or probing the interaction is very easy. All we have to do is split the file by whatever the categorical predictor is. So in this case, we split the file by sex, and then we ran separate regressions for men and women. So one regression asking the question, does signature size predict narcissism for men? And then a second regression, does signature size predict narcissism for women? And what we found when we ran those two simple regressions is that there was a relationship in one group but not in the other. So for women, there was a positive relationship between signature size and narcissism, but for men, those two things were not related. So in other words, the relationship between signature size and narcissism depends on a person's sex. That's where the interaction is coming from. We also talked about how to do dummy coding when you have a categorical predictor variable that has more than two levels. So the example that we looked at was if we wanted to code which program you're in, experimental, clinical, or counseling, to use in a regression. And what we saw is that you actually need to create multiple dummy variables in this situation. So things get a little more complicated. In fact, the number of dummy variables you need to create is equal to the number of categories minus 1. So in this case, we have 3 categories, experimental, clinical, and counseling. We're going to need 2 dummy variables. And when we're creating dummy variables like this, the first thing we have to do is decide which of these categories is going to be our control group. In this case, I chose to make experimental the control group. That's a pretty arbitrary decision. But whatever we choose the control group to be, they are just going to get zeros for all the dummy variables. Control group always equals 0. The other groups will get 1s each one time. Okay? So at any given point, a dummy variable is comparing our control group against one of the other groups. So in this case, dummy 1 would be comparing experimental against clinical. Dummy 2 would be comparing experimental against counseling. And in our regression, the dummy variables go in as separate, but we know they're kind of the same thing, right? They're just 2 different parts of the program variable. And then when we go to test an interaction, because we have 2 dummy variables, we're also going to need 2 interaction terms. So again, things get a little more complicated when we want to include a categorical variable that has more than 2 categories in it. So that leads me into the example practice problem that I gave you guys to do for homework. Just to recap what the problem is about, a few weeks ago, we talked about the difference between maximizing and satisficing, and we learned that maximizing tends to be negatively correlated with happiness or well-being, right? People who score higher in maximizing tend to be less happy, less satisfied. However, the studies that found that were all done in Western cultures, in the United States, where choice is not only abundant, but also something that we value because we're very individualistic. So the question is, what about other societies? What about Eastern cultures, for example, that are more collectivist? Would this same relationship hold true in those cultures? In other words, does the relationship between maximizing and well-being depend on what culture you live in? So here's the problem itself. We had 3 different cultures, China, the US, and Europe. And for the participants in this study, we knew 2 pieces of information. We knew their maximizing score, where higher scores mean that they're more of a maximizer. And we know their well-being score, where higher scores indicate higher levels of well-being. So what I asked you to do is the following. First, dummy code society, where China is going to be your control group. So you're going to have one dummy variable that compares China against the US, and you're going to have a second dummy variable that compares China against Europe. Because we're going to compute an interaction term here, we need to mean center our continuous predictor, which is maximizing score. Then we're going to compute not 1, but 2 interaction terms because we have 2 dummy variables. So we're going to need 1 interaction term for each of the 2 dummy variables. And then we'll run a hierarchical regression to see if the interaction is significant. Did adding the interaction make the model better? So I added some new slides here that weren't originally on the PowerPoint. They're all now available on our website, so you can follow along and we can walk through these examples step by step. The first thing we need to do is dummy code society. We want to make China our control group. But before we can do that, we need to know how is that variable coded as is, right? So if we go to value labels, we see that right now, at the start, society is coded as 1 equals USA, 2 equals China, 3 equals Europe. We're obviously going to have to fix that, right? But it'll be a lot easier if we know where we started so that we can know what we need to change our variable to. Here's the syntax that we're going to use to compute our two dummy variables. So for dummy 1, we want to compare China against the United States. So we know that China, 2, is going to get changed to 0 because our control group always is a 0. Since we're comparing China against the US, we're going to make US 1, so 1 is going to stay the same. And Europe is just going to get ignored here. So Europe 3 is going to become a 0, giving us a variable called dummy1 that compares China versus the US. This second line here isn't technically required, but I highly recommend it because it makes it a lot easier to keep track of which dummy variable is which. So I just added a line here that makes it so that dummy1 will show up as China versus US. Our second dummy variable is going to compare China against Europe. So again, China is going to be a 0 because the control group is always a 0, so 2 changes to 0. But now, we don't care about the US. 1 is going to become a 0. We do care about Europe. So we're going to change those 3's to a 1, giving us a second dummy variable called dummy2 that's going to compare China against Europe. After we run all of this syntax, we're going to have these two new dummy variables at the end of our data file that we didn't have before. Again, dummy1 compares China against the US. Dummy2 compares China against Europe. Second step, we need to mean center our maximizing score. First, we need to find the mean for maximizing. So here's the mean, which we found from frequencies, like we've been doing for quite a while now. Then with one simple line of syntax, we can create a new variable. I called it maxim centered, but you can call it really whatever you want. It's equal to the person's maximizing score minus the mean. So that number right here, we just plug in here. We're going to get a new variable for each person giving us their mean-centered maximization score. So for person number 1, for example, their maximization score was above average, so their mean-centered score is positive. For person number 3, their maximization score was below average, so they end up with a negative mean-centered score. Created 2 dummy variables, 1 mean-centered variable, and then 2 interaction terms that we're going to use for our hierarchical regression. In step 1, or block 1, we're just going to put in the main effects. So we're going to put in society, which is represented by our 2 dummy variables, and we're going to put in maximization, which is our mean-centered maximization score. Remember that our outcome here is well-being. That's the thing we're trying to predict. In block 2, we're going to keep the 3 variables we had in block 1, but then we're going to add the 2 interaction terms. So we have a total of 3 things in block 1, a total of 5 things in block 2, the only difference being the 2 interaction terms. When we run this, the first place we're going to... Oh, I'm sorry, I forgot one thing. Make sure you, in the statistics menu, check the box to request the R-squared change statistics. That'll give us the tests that directly compare block 2 against block 1, which is the next thing I was going to say. That's the first place we're going to look to see if our interaction was significant. Okay, so here under the model summary, we've got model 1, which is just our main effects, and we've got model 2, which adds the 2 interaction terms. SPSS gives us a little cheat sheet down here to remind us which variables are in which blocks, And looking at the F change test for block 2, we see that block 2 was significantly better than block 1. In other words, adding the interaction terms made the model significantly better than it was without the interaction terms. Now, since we have 2 interaction terms here, we might want to look at them separately to see whether only one of them was significant or both of them were significant. So if we want to look at the 2 interaction terms individually, we go down to the coefficients table and we get a separate row for interaction 1 and interaction 2. In this case, we see that both of them were significant. Okay? So remember that interaction 1 is the interaction between maximizing score and dummy variable 1. And dummy variable 1 compared China against the US. So the fact that interaction 1 is significant is telling us that the relationship between maximization and well-being is different in China than it is in the United States. Using that same logic, interaction 2 being significant tells us that the relationship between maximization and well-being is different in China than it is in Europe, right? Because interaction 2 involves dummy variable 2, which compares China against Europe. So that's a long-winded way of saying what we're going to do next is we're going to split our file by society and we're going to run separate simple regressions. So here we're going to end up with 3 separate simple regressions, one just with Americans, one just with folks in China, one just with folks in Europe. To do that, we go to split file, select compare groups, move over society. We're always going to split by the categorical predictor. And then we go back into the linear regression menu that we just were in a few minutes ago. We want to reset it, right? Just clear out everything that was in there so we can just click the reset button because all we want to do now is run a simple regression. So we're going to put in maximization as our predictor and we're going to put in well-being score as our outcome. It doesn't really matter here, to be honest, whether you use the original maximizing variable or the mean-centered one because we're not testing an interaction. So it won't make any difference in our results. The important thing is that maximization is our predictor and well-being as our outcome. So what we're going to get on the next slide are 3 separate simple regressions testing this relationship in each of those societies separately. So here they are. Here's the simple regression for the US, for China, for Europe. And what we see is that in the US and Europe, maximizing is negatively correlated with well-being, right? In the US and Europe, people who have stronger maximizing tendencies are less happy. But in China, that's not the case. In China, there's no relationship between maximizing and well-being. So this is where our interaction is coming from. We have a relationship between maximizing and well-being in some groups, but not others. In other words, the existence of that relationship depends on what society you live in. So here's how I wrote up these results. I had asked you to produce a table, so I'll show you what the table looks like as well. The first thing we need to do is just describe our model. So a hierarchical regression tested maximizing, society, and the interaction as predictors of well-being. And we're going to cut right to the chase here and say the interaction made the model better. And those are the results of the F-change test from the model summary table a few slides back. It also tells us how much of the variance was explained by that second model. We also say here that both of the interaction terms were significant, and we can show that in the table up here. So all of this information comes from that coefficients table from a few slides ago. What we care about most here is that both of these 2 interaction terms were significant. So for each of these predictors in all Model 1 and Model 2, we have both unstandardized beta and standardized beta. As always, I'll be really clear about what exactly I want you to provide on an exam or anything like that. This is probably overkill, to be honest, but I just wanted to make sure you saw all that information out on the page. So since both of those interaction terms were significant, we went and we split the file and we ran simple regressions. And what they found is that those 2 variables, maximizing and well-being, were related in America and Europe, but were not related in China. So again, that's where our interaction is coming from. That relationship was dependent on what society a person lives in. And as it turns out, that's exactly what they found in the study that this example is based on. They described doing a hierarchical regression. They actually had 3 steps because before they tested the effects of maximizing in society, they controlled for a whole bunch of things. So we talked a few weeks ago about how if you want to control for certain variables, especially variables that have previously been shown to be relevant to whatever hypothesis you're testing, you can put those variables in your first step and then build upon those. So I guess income kind of makes sense. Education has previously been shown to be correlated with well-being, so they wanted to make sure to control for those variables to rule out those variables as alternative explanations for their findings here. They found significant interactions. And here in the table, they report both both interaction terms, which they added in their final block, and both were significant. And then they actually showed their interaction in a graph, which is something we're going to learn how to do very soon. So in both the US and Europe, maximizing showed a negative relationship with well-being, but there was no such relationship in China. So all this is for each of those 3 societies, it shows the regression line for that group. So in the Europe and US, you can see there's a lot steeper slope here, indicating a stronger relationship between maximizing and well-being. But in China, it's a pretty flat slope, right? Telling us that relationship is not significant. So showing interactions in a graph like this instead of a table can obviously be a lot more visually appealing and easy for a reader to understand. So that's something we're going to come back to, I think, 2 lectures from now. All right, hopefully this helped you get some of the rust off from the past 2 weeks. Starting with the next lecture, we'll dive into some new stuff.